Hello, today we will be talking about first order differential equations, and we're going to be looking at this problem that I have written down right now, and we're going to solve it together. So, to do this problem, we must know this equation, y prime minus a of t times y is equal to b of t, and for this problem, we're going to be turning it into that formula. Another formula that we're going to use is this, but we won't get into it till later. So just take note of it for now. Okay, so the first thing we want to do to our problem is divide everything by t so we can get y prime alone. From here, our problem is already looking really similar to our formula. The only thing we need to do is move 2y over t to the other side. So this is perfect. Our problem is just like the formula that we talked about in the beginning. Just to clarify, a of t is equal to 1 over t, and b of t is equal to t to the second times sine of 2t. Now that we're here, we're going to go back to our second equation that we had talked about and do some interesting things. As you can see, it's the exact same equation as the one above it, except every single character, or variable I should say, is multiplied by mu. Let's get back to our equation that we were at, and let's multiply everything by mu. And now we're left with this. Right now, mu does not have a value, but we know, according to our formula, if you go and look back at it, mu times t squared sine of 2t is actually equal to something. It's equal to mu times b of t, which is equal to mu times y prime. So as you can see now, this equation and this equation are both equal to each other. So we can literally cut out the middleman and make them equal to each other. Now we need to use the product rule to find out what mu times y of prime is. It's equal to that. So now looking back at our original equation, we can substitute mu times y of prime for the equation we found using the product rule. Great, but now we see that mu times y prime is on both sides, so we can cancel that out. And now we're left with this equation. But we still have three variables. So, but guess what? Y is on both sides, so you can go ahead and cancel both of those out. So now you're only left with two variables. Now you just need to put them on the same side. So now you have negative 2 over t is equal to mu prime over mu. Now, since you only have two variables, you can integrate with respect to t and mu. For t, negative 2 over t dt is going to simplify to negative 2 ln of t plus c. And for mu, d mu over mu, the integration of that is equal to ln of mu plus c. Of course, there only needs to be one c constant, so it's put on the side with the t. And then both sides are raised exponentially because of the logarithmic function. The previous way of writing it can get a little daunting, so I rewrote it like this to make it more intuitive for someone to grasp. So e to the raised to the negative ln of t is just 1 over t. And then e raised to the c is just going to be c because it's a constant. And then e raised to the ln of mu is just going to be mu. And so we have our final answer for what mu is equal to, which is c over t squared or 1 over t squared. So now that we know what mu is equal to, we can find out what y is equal to. So let's start out with the equation mu times y prime. Now we know that this equation is equal to something. Can you guess what it is? It's equal to mu times b of t. Do you remember what b of t was? B of t in this equation was equal to t to the second times sine of 2t. And mu, as we just found, is equal to 1 over t to the second. Now we just need to plug in for mu and b of t, and we get this. And would you look at that? T to the second. They both cancel out. That's huge. That's great. Now we're left with this equation. And all we need to do from here is just take the antiderivative of both sides. And for the left side, the prime and the antiderivative cancel out, so we're just left with y over 2t to the second. And yeah, it's just a simple antiderivative for the right side. And of course, don't forget that plus c. That's very, very crucial. So now we have the equation for all possible solutions. Now, it's all possible solutions because we do not yet know what the C constant is equal to, and that's what we're going to find. So let's just rewrite the equation with given what we know. So in this instance, when t is equal to pi over 2, y is going to be equal to 0. So that we take the solution that we just had for all the solutions possible, and we substitute 0 for y, and pi over 2 for t. And as you can see here, I did that for us. So at this point, it's just basic algebra. One side is pi over 2 squared, and the other side is pi over 2 squared. And you just need to find out what c is so that, it equals 0. It's pretty self-explanatory at this point. And you actually find out that c is equal to negative 1/2, and so you just plug it into your all solutions equation that we found before, and that is your final solution for the initial final solution.